If you're on a journey of solar panels, you might have heard the word inverter. What is it? What does it do? How does it work? And how is it going to benefit your solar system? And how do we know we've picked the right one for you? Today, I'm going to be breaking down all the basic key things about an inverter so that when you're picking one and when you're making the decision, you know all the things that there is to know. Let's go. What does an inverter do? Most people don't realise that the current that's generated from solar panels is in a slightly different waveform to the ones that we use in our sockets. What do I mean by this? Solar panels generate current in what's called DC. This is basically a straight line waveform. But we use power, so when I boil a kettle, that's in AC. So we need an inverter to effectively convert this current from DC to AC. So there are 5 key functions to an inverter. There might be a couple of little ancillary ones, but these are the ones that you would come to expect as a home user when you purchase an inverter as part of your system. The first one is to convert the energy from DC to AC. The next one's tracking performance and home usage. We fit a little clamp around the incoming supply to your home. So when you turn a kettle on, the inverter's able to pick this information up and make decisions on what to do with the energy when it's being converted either from solar or from the battery storage. The inverter's also able to give you an idea of what you're actually generating in real time. So you can make decisions on, okay, well, I'm generating quite a lot today. Let's put the washing machine on. Let's put the dryer on. Or if it's a bit of a cloudy day, you might think, I'll put that on tomorrow. The third main function is storing it inside of battery storage. Now, I'm going to deep dive a tiny little bit on battery storage later on in this video itself, but effectively, your inverter can convert the DC, step that voltage down into a lower voltage DC often, store it, and then when we turn our kettle on, the power can be converted via the inverter from DC to the usable current of AC. Now this is great. Let's say you're at work during the middle of the day. You've got lots of solar generation. That battery storage would be there for later on. So when we cook our tea, we're effectively able to store that green renewable energy and use it later on in the day. It's a thing we call load shifting. Let's say there's no one at home. There's no demand in the house. Your battery storage is now full. The fourth main function is exporting the energy out to the national grid. So as engineers, we can write out to the grid, get permission to connect, and you can effectively be your own little power plant. And energy suppliers will effectively pay you a credit on your energy bill for every unit that you send out to the grid. So during the likes of summer months, you can build up a credit on your account, and then in the winter months, when you do need to still purchase energy, hopefully off peak into that battery, you can use that credit from the summer to offset against your winter debits. So the fifth option is something called whole house backup. This is effectively alongside another part, which is called a gateway. Your inverter can actually supply power to your home in the event of a power cut. So there's specific setup that's needed for this, but most modern inverters can now offer this as part of it. It's just something you'd need to mention to your installer. So what are the different types of inverter? There's not just a one product and that's it. There are slightly different styles of inverter in the way that they work for slightly different applications. So I'll try and break this down in the easiest way I know how. I'll start simple, and then I'm going to start to add more functionality. So where inverter started was a string inverter. This is where solar's generated in DC, it converts to AC, and then it's either a use it in the home in real time or lose it, export it to the grid effectively. So out of the 5 functions we had earlier on, effectively a string inverter can make it usable, monitor what your home is doing, and export. You don't get the other benefit of storing or getting house backup with a string inverter. In the event that the power goes out, your string inverter simply turns itself off. Now there's a smaller version of a string inverter, and this can often be referred to as a micro inverter. This is at panel level. So unlike a string inverter that's often maybe your attic or your garage, for example, these have become places we would install one of those. A micro inverter, it's on the back of the panel. So what happens is the panel converts DC to AC, and then the actual power goes down in AC. It works very similar to the way which a string inverter works. So why would we use a microinverter instead of a string inverter? First of all, string inverters are cheaper. The main reason for microinverters is like higgledy-piggledy roofs, because we need a minimum number of solar panels to go on an inverter for it to work. So by having a microinverter, by it being really small, we can get away with less solar panels. These are great for awkward roofs. These are also great for individual panel level control. So stuff like commercial buildings is another classic example where we want to be able to monitor what all the panels are doing in real time. But the majority of domestic houses in the UK, they're probably not going to go for a microinverter. These often push the cost up somewhat. And from a risk perspective, so if you're thinking of weighing up your inverter options, if a microinverter breaks, it's up on the roof. Your installer or another installer would have to build a scaffolding up, take the panel off in order to be able to maintain it. Often microinverter warranties don't cover the cost of scaffolding, so just be a little bit cautious when you're picking like your type of inverter. That leads me quite nicely on to the next style of inverter, which is a hybrid inverter. And what the hybrid basically indicates is that we can install battery storage into that inverter effectively. We don't need a separate one. It can do both functions, converting the DC to AC. It can monitor what you're doing inside of your home. It can export to the grid, but it can also store that energy inside of battery modules. This next to me is a hybrid inverter, and these below are battery modules. So essentially we can add them to them. And this is what I would say would be the most common type of inverter that's there. And as I mentioned earlier on in the video, these can also, subject to some extra parts, a thing called a gateway, these can also offer you house backup. Now another version of these hybrids is what's called an all-in-one. Now the system next to me, it's quite good I've got this next to me, because you essentially we have our inverter at the top and we have our battery modules that sit below. However, there are some units, like the Powerwall 3 by Tesla Energy, where the inverter and battery essentially come pre-formed together. So they come in one size, whereas the one that's behind me, you essentially get a stackable version of the same. They're effectively the same system, it's just manufacturers do things slightly differently. You can also install inverters and battery storage, so those people that can't have solar panels, or maybe you're going like an extension of your house and you're not quite ready for them, you can also install battery storage by itself. So you don't always need solar panels to wire into an inverter. With a battery only system, you still need an inverter. You still need the engine. Think of the battery as a little bit like the fuel tank. We've got our power, which is a bit like the fuel. We always need an engine in this process. So regardless of whether we have solar panels or not, as the case may well be, you can have battery storage by itself. But in all scenarios, we always need our inverter, our engine, to be able to convert the current from DC, either in the batteries or from the solar panels, to the usable AC current that we use in our homes. So another common question I get asked as an engineer is, how do I size the right size of inverter for me? Because there are so many different styles and types and sizes of these systems, and these are done in a size we know is kilowatts effectively. Think of kilowatts a little bit like the throughput of the amount of power that can go through the inverter. So if I have a kettle and the kettle is 2 kilowatts and my inverter is 2 kilowatts, when I turn my kettle on, whether it's from solar or it's from the battery storage, this power can convert at a rate of 2 kilowatts. Now, if I then turn the toaster on, and that's using another kilowatt, if that inverter isn't big enough, that 1 kilowatt's going to be drawn in from the grid. The systems run in what we call parallel. So it's not the case that if we go above the inverter's capacity that the system either turns itself off or can no longer meet the demand. What happens is the inverter will meet the demand first, up to a point of its maximum speed capability, and then the grid will then top it up, a little bit like what you do currently. But ultimately, the idea of having stored electricity is to be able to use that stored electricity. So this is where the size of inverter matters. We've got to look at the loads that are on your house. So for example, if you're just an average household user, you've got a washing machine, dryer, we don't have underfloor heating, we don't have any hot tubs outside, and we're relatively low consumption, then a smaller inverter will do, 5 kilowatt or below. Now let's say I'm a family of 4, my consumption's higher. If it's anything like my house, my washing machine and dryer is on permanently. But equally you might say, well, I don't have a heat pump. I don't have a dryer, for example. What we want to make sure is that this inverter, when we turn on these loads, my washing machine, my dryer, my oven, can effectively pick the power up out of the battery fast enough and meet these demands simultaneously so we don't draw in from the grid. So in this scenario, a medium size inverter, say 5 kilowatts, say 8 kilowatts, would be about right. 8 kilowatts being the speed in which it can be pulled up from the battery storage. Then, if you're a much higher demand household user, for example, some of the properties that we've seen with heat pumps, hot tubs, underfloor heating, bigger cookers, you might have 2 ovens, for example, then in that scenario, we're going to be looking at the bigger size again. Now, this isn't an indefinite size where we can just keep going and going and going and going. There are limits to how fast we can pull power through and meet the demand to your home. Normally that sits about 12 kilowatts as a maximum on a single phase supply. Like the SIG Energy Sigen store, the inverter behind me, they make a 12 kilowatt version. Now you might go, I'll just buy the biggest one whilst I'm at it. Why not, hey? Well, the reason why you wouldn't do that is because of expense. The bigger the inverter gets, the more components that are involved, the more time it takes often to install these systems. And at the same stage of the game, we also need to use thicker cables, bigger isolators, more distribution, on often, subjective, depending upon the install. So each time we're adding a few pounds to our install cost. And actually, if you're a retired couple with a bungalow, you've not got heavy usage and there's no real intention of increasing it, you're not going to get a great return on your actual investment. The holy grail of a solar system and why most people install them is ultimately we want to make savings on the bills, get grid independent, and almost have like predictability of our future energy bills. If you want the house backup element, this is where I'd add one caveat to that. So this is where in the event the power goes out, let's say you live somewhere rural or you're prone to blackouts, then often you'll want a slightly larger inverter for that scenario. Why? Because if we're mid-cooking tea, we want to make sure that this inverter, when it goes off grid, can effectively meet these demands. So that's probably the only exception to that rule. So how do I know the inverter is the right size based upon the number of solar panels that I'm having installed? Now, something unfortunately happens in this industry is we get a lot of sales companies that have come into the fold. They're interested in screwing as many panels and as many boxes up to your walls as they possibly can do. So often what these companies will do is put what's called oversize your inverter. So inverters can sometimes be oversized slightly, but they do this and this essentially reduces the amount of generation that you can get from your system. So as a bit of a sense check, and so that you know you've got the right size inverter for your solar panels, solar panel peak output, so this is when we add the number of solar panels together. So let's say I've got 10 440 watt panels, that's like 4.4 kilowatts. If I've then got a 4 kilowatt inverter, they're roughly speaking about the same size as one another. That's what we want to see when we're going through the design process. Let's say my inverter can take this and I now double the amount of solar panels I put on the inverter. So I now have 8.8 kilowatts worth of solar on a 4 kilowatt inverter. It's like having a little engine and lots of fuel. It can't process, the inverter can't process it quick enough. And essentially it's like someone standing on a hose pipe. That DC current can't be converted any faster. Your inverter's pedaling as quick as it possibly can do, but it can only go at 4 kilowatts. So making sure your inverter is roughly speaking the same size as your solar panels prevents what we call peak clipping. This is where that energy gets clipped off and essentially gets wasted. You can't use it, you can't utilize it. You just want to make sure that as a sense check, the solar panels are roughly speaking the same size as your inverter. So other questions I often get asked are around like installation considerations. So where can inverter be mounted? What do the sizes look like? Can I put them in an attic, for example? So I'll try and unpack that as well. I think a common myth that I come up against is where people think like, because the inverter is a bigger size, so let's say one's 3 and one's 12 kilowatts, that all of a sudden the inverter gets bigger. Actually, like the range, like the SIG Energy Sigen store behind me, the inverter in this scenario is the same size in terms of width and depth, regardless of whether you buy the 3 or you buy the 12, so the smallest or the biggest one in the range. And from a size point of view, like these are about 700 mil wide. So normally I say, if I can stand with my back up against the wall a battery storage system would normally stand where my body would be effectively. So if you allow that in terms of a spacing, then that's normally a good starting point. So where can inverters go? Now, if you've got a string inverter, these can go in a loft, they can go in a garage, they can go outside as well. If you've got a micro inverter, well, they will be up at panel level, so you're never really going to see them. However, with a hybrid inverter, when it's coupled with battery storage, there's some best practice guidance that we've got to follow as installers. I think this best practice guidance will actually become part of what we know as BS 7671, our wiring regulations later on this year. And PAS 63100, which is this best practice guidance, basically says, look, don't install it somewhere daft. Don't put it in a loft. To be honest with you, good luck to anyone trying to install battery storage in a loft anyway. These are like best part of 100 kilos a unit. You'll end up pulling your back out of place in the process. So you'd probably never put that anywhere. We don't want to put it in someone's bedroom next to where they're sleeping. I don't think that would be a wise idea. We don't want to be putting hybrid inverters and battery storage underneath stairs, unless it's got fire compartmentation, for example. And we also normally won't put them within a metre of entrance or exit inside of a building. Now, you might be going, well, where can I put it? Garages, outdoor places. Ultimately, this is the job of the engineer that's going to come out and have a look at your system. If I was ever picking an installation company, I would always make sure that, look, I've got a reasonable idea of, from a quote point of view, what it's going to cost me, and then I would make sure that a qualified engineer is coming out to my house in order to be able to survey my property. So they're then going to give me an idea of where the battery storage can be placed, fair considerations for my home. Bear in mind that no two houses are the same. When we have best practice guidance and regulations, they're all there to guide us as electricians, engineers, of where to actually place these. So I would always ditch the remote quote, because the amount of times I've seen those go wrong, and actually instead you want to be going, look, I'm thinking of spending 10 grand, 15 grand, 5 grand. You're thinking of spending money in the thousands. Really, you want to be kind of saying, look, I want someone to come around, I want someone to have a look, and I want someone to give me some guidance. I want to know where the cables are going to run from my solar panels to my inverter. I want to know where my inverter can and cannot be installed, and why you're thinking of putting it there. Is it because it's just easy for them to install there? Or is it actually because that's technically the best place for me to actually have it in my home? There are a few common questions I get asked, whether that's been in comments on our YouTube videos or whether that's in person when I've gone over to survey people's properties. Do solar panels work without an inverter? Keep it short and sweet, no. What happens if the inverter fails? Now, this depends on the type of inverter. If it's a string inverter or a hybrid inverter, it's really just a case of swapping that part out. If there's a new version of that inverter, then you may also need to upgrade the battery storage. Systems like the SIG Energy side install that's behind me are backwards compatible. So what we know is in the future, a couple of years from now, if they bring out a new model, the idea is they're trying to build in backwards compatibility as part of it. But if you have a microinverter and that fails, well, that's interesting, because the microinverter manufacturer will only cover the cost of the replacement microinverter. So if I'm 10 years from now, you're outside of your insurance-backed workmanship warranty with your installer, the costs would be on you to facilitate not only the inverter replacement, but also the scaffolding. So picking the right type of inverter and giving that careful consideration is always important. Can I add any battery with any inverter? Well, first of all, the only inverters that will work with battery storage are like a hybrid or an all-in-one, one battery and inverter all formed together. Mixing and matching inverters and batteries, in my professional opinion, is never wise. Why? Because if the battery fails, the inverter manufacturer will blame the battery manufacturer will blame the inverter. We're just prone to way more problems when it comes to aftercare of these systems. What you'll often find is if people are in a race to the bottom to try and fit the cheapest possible component, they might technically work together, but ultimately, like, you're spending thousands of pounds on this system. You want your inverter and your battery storage brand to match, so that if there's a problem with your inverter or your battery, one's not playing the blame game effectively. Another common question is, how long will an inverter actually last? Well, ultimately, if they're well looked after, normally test and inspected every 5 years, clean, tidy. We're not putting items on top of them, coats and stuff along those lines, and they're left plenty of space to ventilate. Most modern inverters will be warranted for about 10 years, and their lifespan could be effectively about double that normally, even longer. Look, I've seen inverters that are, best part of 20 years old and still ticking along. Inverters can be repaired as well. I think, however, with modern installation, inverter costs, particularly like string inverters, are only a few £100s, and then you might pay a couple of £100 for an installer to physically install it. So often repairs don't tend to come into the mix. But inverters themselves are actually very straightforward to kind of swap out and maintain, as long as they're on the ground floor, of course. Are inverters noisy? Well, that depends on the brand. What you'll often find is on much larger inverters, like the 10 and 12 kilowatt version of the Sig Energy Sigen Store, have fans in to try and keep them cool when it's overperforming. So effectively where that performance is giving it a good pelting. So some do make a little bit of noise, most don't. I normally advise for the mass majority of inverters about the noise of a fridge effectively, so they're not very noisy at all. You probably wouldn't want them in your bedroom, but if they're in the garage, then you're very unlikely to be able to hear them at all. They're not very loud at all, to be honest. Do I get given an inverter with my solar panels automatically? Well, yes, ultimately the solar panels are not going to work without an inverter, but you've got to be careful sometimes on this. As soon as you start searching solar panels, your social media feeds will probably be bombarded with package this and package that and package the other. You've got to be quite cautious in terms of which inverter and battery storage brand that you're getting as part of your quote. My recommendation is always ask for a breakdown. I'm not talking like labor and parts. I'm talking like, right, so I've got my inverter. How much are you going to charge me to fit that? How much are you going to charge me for my battery storage to install that? So you can make sure that you're getting the right parts and also a fair and reasonable price for the job that's being done. Another question I get asked is, how different are the actual brands that you would get on the market, and what difference does that really make? It's a little bit like going out and buying a washing machine. You can get your budget end brands, and I'm not saying there's anything bad about these. There'll be lots of people that'll be quite happy with these products. These are like your Fox ESS, your Solax, your SunSync. They're a little bit like white knight washing machines. You then have kind of like your mid-range products. So this is stuff like the Sig Energy Sigen Store, for example. These are kind of like your mid-range stuff, like your Bosch washing machine effectively. And then you've got your like peak performance kit. So this is like the bigger Sig Energy Sigen Store inverters, your 8s, 10s and 12s, and like your Powerwall 3 by Tesla Energy. You're paying a little bit of a premium for them, but they often come with slightly longer, better warranties that cover more. So not only do the manufacturers cover the actual parts and components, but they actually cover the labor to be able to repair them and put them right should they go wrong effectively. So that tends to be what you pay your premium for. Look, there'll be lots of people that will be, as I mentioned earlier, that will be happy with a white knight washing machine, but the majority of people, when they come to pick solar panels and battery storage, pick it as a long-term investment. They want a decent return on investment, and normally it's best to kind of, if you are kind of going, look, I really just want like the best ROI, don't just think what's the cheapest, think what's going to last me the longest, who has the best aftercare and support, who are the most established businesses, do they have good app technology, is my installer actually going to be there in the event this all goes wrong? It's all about kind of like future-proofing your system, not just focusing on what's in front of your nose. You can also get intelligent and non-intelligent inverters. So a non-intelligent inverter will effectively won't link with some of your smart tariff providers. So I've done a full breakdown on tariffs that's on our YouTube channel, but effectively this is where your energy supplier, Octopus, EDF, British Gas, they can directly connect onto your inverter, map your inverter to the cheapest possible prices on the grid. They can also look at like weather forecasting and basically use AI to be able to run an energy model that makes you the maximum amount of savings. When you spend a lot less on your inverters, your cheap end of the market, not all of these inverters offer these intelligent connections or these intelligent capabilities. So it's kind of one of those where it's like penny wise, pound foolish, in that yes, it's cheaper, but actually it's not just about your inverter converting solar to your home. Sometimes it can be about, well, how cheap can my inverter buy energy from the grid to store in my battery storage or supply my home when it's in an off-peak rate? Are inverters waterproof? The mass majority are waterproof. You'll be able to have a look at the data sheet. We're looking for something called the IP rating, and this effectively gives us an idea as installers of these locations that your inverter and battery storage can effectively be stored or housed. The mass majority of inverters and battery storage can go outside, like the Powerwall 3, for example, is fully flood-proof up to 60 centimetres. But there are some inverters and battery storage where they're a bit cheaper, that they ultimately have to cut costs somewhere, and one of the costs they will often cut is this IP rating, so they can sometimes only be rated for indoor use. So this is something you can just check out with your engineer when you come to have it installed. Other than that, thank you so much for taking the time to have a bit of a watch today. If you want to find a little bit more about solar panels, tariffs, we've got some great YouTube videos if you're kind of exploring the world of solar. Thank you.